I am Anil Kumar. Welcome to my series on Venn diagrams. Take this particular video as part of your practice test. I will have 6 or 7 questions here. We'll try to understand how to read a Venn diagram, how to make one, and how to draw conclusions from the given Venn diagram. So let's begin by understanding the Venn diagram itself. From the given Venn diagram, write the numerals that represent each of the following. So we have 3 sets here, A, B, and C, which has S is your universal set. Now we have to read the information and write the numbers which correspond to whatever is given here. You can pause the video, answer the question, and then look into my suggestions. The very first one is complement of A. That really means not A. So what are the numbers which are not in A? That is what we have to list, right? So in this, A means these numbers 2, 3, 4, and 6 come within A. So the numbers which are outside are 1, 5, 7, and 8. So we'll write 1, 5, 7, and 8 in this case, correct? So that is how you have to complete and answer this question. I hope the concept is absolutely clear. Let's take part B now, which is A intersection B union C. That is to say that we have to take all the elements in C, right, union C, plus we have to consider intersection of A and B, right? So A and B intersection means 2 and 4 also, right? So when we combine 2, 4, which is intersection of A and B, with C, we actually get all C and this 2, right? That is what we get. So let's write down the elements. 2, 4, right? So 4, 5, 6, 7 of C and 2, which is from intersection of A and B. So it'll be 2, 4, 5, 6, 7. So I hope the concept is clear, right? What we are trying to do. You can now pause the video, answer rest of the questions. So 2 parts on this. Now we have B intersection C and then complement. So remember this is a dash here, which means complement, just as we had here, means not in intersection of B and C. So what do we had in B and C intersection? 4 and 5. We do not want 4 and 5, but everything else, that is what it is. So outside 4 and 5 is what we're looking for. So leave 4 and 5 and write rest of the numbers. So we have 1, 2, 3. Leave 4 and 5, we get 6, 7, 8. Does it make sense? So that is what complement of intersection of B and C means. Perfect. Now this one. You can now pause the video and answer this one. This is slightly tricky. So we're looking into not A union not C. So not A means outside A means 8, 1, 5, 7 union. Not C means 1, 2, 3, 8. And then we are saying intersection with B. So that means whatever all this will be within intersection of B, right? So now, since we have already answered rest of the questions, here, let's try to understand. When we say not A union not C, that means outside A and outside C. So we are actually looking for everything which is kind of outside this box, these 2 sets, right? So we are left with outside means 1 and 8. Do you see that? So that means it is not A, right? Not within A and also not within C. Now we're looking for intersection with B. So the only thing left with intersection of B is the number 1, correct? So that number 1 is left for us. So that becomes the result. Does it make sense to you? So that is how we are going to answer this question. Now as a practice, you can actually add to this list and you can work like this, like B union C and that union of A, right? So you could write what the elements will come in this particular set. Perfect. So I hope that is making sense to you. So let's move on and take the next question, where we'll try to fill in the or shade the Venn diagram from the given conditions. So I've taken up two Venn diagrams here which you need to shade. So the question here is, on each of the Venn diagram below, shade the region which represents the given set. The set given to you is written under the Venn diagram: A intersection B union complement of C. The second one here is complement of A intersection with union of B and C, right? So that is what it is. You can pause the video, answer the question, and then look into my suggestions. Now, once you do the shading, after that we have the other question, which is, we have already shaded two Venn diagrams here where set A, B and C are shown, and that is the shaded portion. Now the question is, given sets A, B and C as shown in the Venn diagram, name the shaded area in each of the following. So have a good look at it and try to name the shaded area. Perfect. Okay, so let's begin with the first question now. I hope you have seen both of them very clearly. And now let's see how to shade and how to read the shaded portion. Rather, let's begin with this one itself. Okay. Now in the first one, let's call this as lowercase a and let this be set B. The shaded portion shown to you here is completely that C, right? And a portion of B. The portion of B which is shaded does not include A. So how can you write this? So clearly we have the set C altogether with union of what we have here is something which is outside A but inside B, right? So it is outside A and inside B. So I could write this as A complement, that means outside A, and intersects with set B, so intersection with B. Does it make sense to you, right? So that is how you could name the shaded portion in the given Venn diagram A. Now in B, how will you name it? We have complement of A, everything outside A has been shaded, right? So clearly it's union of complement of A with something inside. And what is this inside shaded? Now inside does not include C, but it includes everything in B, not C, right? So it should be not including C, right? So it is basically intersection of not C but B, right? So it is intersection of not C and B. Does it make sense to you? So that is how you could name it. So have a good look at it. Try to understand how do we write the shaded portion in the given Venn diagram. Correct? So I hope this part is absolutely clear. And now let's take up the first question, which was to shade. Let's try to shade the region asked for. The first one is A intersection B union not C. So union not C means everything outside C will be shaded for sure, right? So clearly everything outside C means, without thinking, let me shade all this which is outside C, right? That is my first thing to do, save, right? So this is all outside C because it is union complement of C, right? So outside C I am shading everything. Perfect. Now it is union with A intersection B. So where is A and B intersecting? So I have already taken a portion of A intersection B. Now this is the portion left. This is A, right? And that one is B. So this portion is already taken. So this is left. So I'm going to shade this portion also. So that is intersection of A and B. Of course, this is also intersection of A and B. So A intersection B is this whole band here, and outside C is all that. Perfect. So that is how we are going to shade it. Is it clear to you? Right. So that is how we do it. Now the next one here is outside A. Right. So outside A, complement of A, but intersecting with union of B and C. So outside A intersecting with union of B and C, that means now we cannot take anything inside A, right? It is intersection with union of B and C. So union of B and C is everything here, right? So this portion here should be the portion, correct? So B and C union and outside A. So that is the portion which we are going to shade, correct? So in this case, that is the result. So I hope now the concept of shading in the Venn diagram is absolutely clear, right? So does it make sense to you? So we have A, B union C, which is everything but intersecting with outside, a complement of A. So nothing inside A gets shaded. So this portion of B union C, which was inside A, has not been shaded. Perfect. So that is how you are going to shade the Venn diagrams, right? So now let me give you a test question here for you with only two Venn diagrams. So we'll have two Venn diagrams A and B. I mean two sets in the Venn diagram A and B. So this is my set A and this is my set B. What you need to shade here is intersection of not A and not B, right? So this is what you need to shade, and that is your test question. Perfect. The question here is, in a class of 30 students, 17 are studying politics, 14 are studying economics, and 10 are studying both of the subjects. Illustrate this using a Venn diagram. Find number of students studying neither of these subjects. Find the number of students studying exactly one subject. So let's first create the Venn diagram. There are 30 students in all. So in our set, we have, let's call the superset as with 30 students, right? 15 students, 17 are studying politics and 14 are studying economics. 10 are studying both. So basically, we need to consider two sets here. One set for students who are studying politics. The other one, the students which are doing economics. Right? So these are the two sets for us. So let me call this set P for politics and E for economics. Now whenever we are given like this, we have to start from inside. So what is common to both? So it is given 14 are studying economics and 10 are studying both the subjects. So common is 10. Correct? So that is both the subjects. So the intersection of politics and economics is given to us as 10. Right? Now, total number of students studying politics is 14. 10 we have already taken here, right? So those who are studying only politics should be how many? Should be 4, right? Then only you get 4 plus 10 as 14. I hope that part is clear, right? So 4 plus 10 becomes 14, right? So that will give you the answer for or distribution of politics. So 10 of these are doing both the subjects. 17 are studying, I read it wrong. 17 are studying politics, so this will be, politics will be 7. 17 are studying politics, 14 are studying economics. So 4 will come on economics side. Is that clear to you? So that is how you are going to show the information on a Venn diagram. Now we can answer all the questions. So first part is done for us. The Venn diagram is right there, right? So question here is, find the number of students studying neither of these subjects. How do you figure that out? Now the students who are studying either of these subjects will be how many? Let's add them all, right? So number of students who are studying both politics, or economics, is basically equal to sum of these, which is 7 plus 10 plus 4. So 11 and 10, 21, right? So this is all the subjects. But we have in all 30 students. The question here is find number of students studying neither, right? So that will be 30 minus 21. So that gives you the answer for students who are not studying any of these subjects, which is 9, correct? So for B, we have 9 students, correct? That is outside. The total was 30 for us. So if you add them, now you get 30, right? Find the number of students studying exactly one subject. So only politics and only economics is 7 and 4. So the answer is 7 plus 4, which is 11, correct? So that is how you would actually answer this. Another way to do this will be total number of students who are doing politics plus number of students who are doing economics, take away their intersection, right? So that will give you the answer directly without even looking at the Venn diagram, correct? So if you fill in the values, which you know is 17 plus 14 minus 10, you will get your answer 21 minus 10 as 11. Perfect. So that is how you will do even without looking at the Venn diagram. Does make sense to you, right? So we have used the principle of inclusion and exclusion. So this 10 is included twice, so it has to be excluded. The question here is, in a school, some of the subjects that it is possible to take are mathematics, additional mathematics, and physics. The Venn diagram shows the combination of these subjects that are possible, and the numbers and letters represent the number of students in each subset. So that's the Venn diagram. Given the number of students taking physics is 123, calculate the value of x, that means only physics. B. Given that 1/6 of those taking mathematics also take additional mathematics, calculate the value of y, and hence find the total number of students taking mathematics. So that's the value of y which you need to find, and this small set is the subset of mathematics students who are taking additional mathematics. I hope that makes sense. You can pause the video, answer the question, and then look into my suggestions. Now let's begin with part A, which says, given the number of students taking physics is 123. So this big circle includes 20, 85, and x, and their sum should be 123, correct? So from the Venn diagram, we know 123 should be equal to x plus 85 plus 20, correct? So this circle here is for the students who have taken physics. So some of them have taken mathematics and also additional mathematics. So that is the equation which you need to solve. So x could be found as 123 minus 85 minus 20. That is the value of x, correct? So when you take this, what do you get? You can use the calculator or just do it without that, as the case may be. So you can take away 85 and 20, and that gives you the value of x as 18. So x is 18 for us. Now let's look into part B. Given that 1/6 of those taking mathematics also take additional mathematics, that means the ratio is 1/6, right? Now in this particular diagram, how many students have taken mathematics but not additional mathematics? That you need to figure out. So clearly the number is 85 plus 8y, right? So this number here is, so mathematics is all of them, of course, but the students who have taken additional mathematics is 20 plus y, right? So let's read the condition. Given that 1/6 of those taking mathematics also take additional mathematics. So this number 20 plus y is 1/6 of all who have taken mathematics, correct? So that is what it means. Given that 1/6 of those taking mathematics, so everybody has taken mathematics, 1/6 have taken additional mathematics. So that means the ratio 20 plus y over all of them means 85 plus 20 plus y plus 8y, correct? All of them. So this ratio is 1/6. You get the idea. So that is what you get as the second equation, part B. Now it's a question of solving this equation. You can cross multiply and then solve it. So let's cross multiply. 6 times 2, so we'll write here 120 plus 6y equals 2. So all this taken on the right side gives us, let's add them, 85 plus 20 is 105 plus 8 plus 1, 9y, right? So that is what you get. Now you can bring the numbers on one side. So 120 take away 105 should be equal to 9y take away 6y. So that is 15 divided by 3, right? So that is equal to, that gives you y as equal to 15. There's less space here, so I'm just squeezing that in, right? So we get the value of y as 3. So first portion we have found, and that is y is equal to 3. Let me write down here. So y is equal to 3. Now we need to find total number of students taking mathematics, right? So that is this big number in the denominator. Perfect. So let's put y as 5 in this and then figure it out. So this denominator is 105 plus 9y, right? So which is, let's use another ink here and then write down. So total number of students who have taken mathematics will be equal to 9y plus 105, correct? And y is 5 for us. So that gives you 45 plus 105 or 150, correct? So the answer here is 150 for students taking mathematics, correct? So that is how this question can be solved. The question here is, some people were interviewed to find out whether they spoke French and Spanish, or neither French or Spanish. Given an E or an epsilon equals to 250, NF equals to 80, and NS equals to 220, use the following diagram to find maximum possible value of W, maximum possible value of Z, maximum possible number of people who spoke both French and Spanish. That means X. So let's get back to this question. We are given that in our sample space, total number of people is 250, right? So that is N epsilon means the superset here is 250. So total number of people interviewed is 250. NF is French speaking is 80. So this whole group, which is written here as F, is 80. Spanish speaking is 220. This whole group is 220, right? So let me make a color code here. So this is French speaking. So this is 80 for us, and the group which is Spanish speaking. Okay, let's give it a color which is bright red. Okay, so that is Spanish for us. Now let's see what we need to figure out. First, maximum possible value of W. So what is here? Maximum W implies minimum X, right? That is simple logic, right? So W is only French speaking, right? So W means only French speaking. Okay, how do we figure this out? Well, since we know these numbers, those who speak French is 80, those who speak Spanish is 220. So if we add them up, what do we get? So if I add those who speak French plus those who speak Spanish, if I add this, I get 300, right? Now 300 is much more than 250. So that means something is wrong, right? So definitely 250 is total surveyed. So that means that X should be overlapping, right? So the overlapping, those who speak both, should be difference of these two. So 50 minimum. So both. So let me write French intersection Spanish. Okay. So that should be 50, right? Now, as we found our logic, for maximum W, that means only French, right? So only French speaking. Which is W, should be how much? From the total French speaking, which is 80, let me write N of F minus what is minimum value of X, right? Minimum value of X, correct? So that is, we have 80 minus 50, and that gives you 30. So this answer is 30, right? So the maximum possible value of W could be 30. So we got one answer. Okay. Now let's look into the second part, which is maximum possible value of Z. How do we get maximum possible value of Z? Well, the only way to get that is if I have a situation where all those who speak French are also speaking Spanish, right? So kind of like this. In that case, we get maximum Z. You get the idea, right? So clearly. So the maximum people who cannot speak both these languages will be in this scenario. Now we know total is 250, and this Spanish speaking world in this surveyed group is 220. So Z should be equal to, okay, let me write down here itself. Z should be equal to 250 minus 220, right? So that could be the scenario. All are just speaking both the languages, French or Spanish, right? So in that case, we get the value of Z to be 30. That could be the maximum possible scenario. So we get the value of Z as 30, correct? Now the third question here is to figure out the maximum possible number of people who spoke both French and Spanish. That means we want to find this maximum value. Well, as we have seen here, this is the maximum value, right? So the maximum value of X, that means both French and Spanish, is all speaking French are also speaking Spanish, right? So that should be 80. Perfect. So that is how we could actually answer this question, right? So we get for part C, the answer is 80 persons, right? So I hope that helps. So if you look into the second scenario, that actually gives you solution of the last two questions, and the first scenario gives you the possible solution for the very first one, right? So I hope that helps. We're almost at the end of our test on Venn diagrams. I hope you appreciate the effort and you kind of learn from this experience. Here is the very last question. In a school, out of 100 students, 15 offered mathematics only, 12 offered chemistry only, 8 offered physics only, 40 offered physics and mathematics, 20 offered chemistry, physics and chemistry, 10 offered mathematics and chemistry, 65 offered physics. Find the number of students who did not offer these three subjects. So that's the question for you. I'd like you to pause the video, answer the question, and then look into my suggestions. Now to do such a question, we need to draw a neat Venn diagram and write down all the conditions given to us. right? So we have three subjects. So let me make three circles representing these sets. So let's say this one is for mathematics, and then let's make one for chemistry and one for physics. Okay, so that is for physics. And we have chemistry and we have mathematics, correct? So as we move along, we will actually read and write down whatever we get. In a school, 100 students. So we know in a sample space, so total number of students in a sample space is 100. That is known to us. 15 offered mathematics only. So when it is mathematics only, so we have taken this 15. So this number 15 will go outside, correct? So that is 15 offered mathematics only. And now it says 12 offered chemistry only. So we have taken this number 12 also, and we'll place this in only chemistry. Now 8 offered physics only. So 8 is only physics. So we'll write 8 here. We've taken 8 also. 40 offered physics and mathematics. So physics and mathematics, that is this common group, we have 40 in all. How do we write this number? That is kind of very tricky. So how do we write 40 offered physics and mathematics? So the combination of these two is 40. So we don't know what this is, which is common to all. So I'll write this as X. And now we can write down 40 offered physics and mathematics, means these two, right? Physics and mathematics. So this means 40 minus X. Does it make sense to you? So this is the most critical part of the whole question. So when you're moving from outside in, we actually want to know what is common to all, which is not given to us. So you can assume that to be X, and now you can work out. So 40, if you add these two, 40 minus X plus X will be 40, right? Now, the next one given to us is 20 offered physics and chemistry. So physics and chemistry is 20. So physics and chemistry is 20. So we can write this as 20 minus X. So when you add these two, it becomes 20, right? So that is the trick involved. So that should work. So we have taken care of 20 offered physics and chemistry. Now we have 10 which are offered mathematics and chemistry. So 10 offered mathematics and chemistry. So this will be 10 minus X, right? So this will be, let me write this as, okay, 10 minus X. Okay, so we have 10 minus X here in mathematics and chemistry. Okay, so we have done all this. You have to be really careful, since very important information, if you miss any one of them, we are going to get wrong result. 65 offered physics. Now when we say 65 offered physics, that means everything within this red circle is physics. So we could now write all this is 40 minus X plus X, right? And then we have plus 20 minus X and plus 8. All this is equal to 65. Now from this equation, we actually get the value of X, right? So let's add them up. So we have 40 plus 20, 68, right? So we have 68 minus X plus X, and then we have minus X equals to 65. Or we can say 68 minus 65 equals to X, that is 3. So we got the value of X as 3. Correct? So since we know now that X is equal to 3, we can actually figure out everything, right? We need to find the number of students who did not offer these 3 courses. So all this total we have to figure out. We have already found that physics alone is 65, right? And X is x is equal to 3. So we can now figure out what is the rest. Perfect. So let's figure out. So we have the numbers which, let's take another ink to write. So all 3 subjects is what? That is what I'm going to write now. So we know physics is 65. So let's take this number 65 plus, let's start from here, outside the red circle. So we have 15 plus 10 minus x, and x is equal to 3. So I'm writing 3 here, right? So this number here will be 10 minus 3, which is 7, right? And plus 12, correct? So that is all what we have. So let's add this up, right? So to add this up, we have 65 plus 570 and 10, 80, 90, 90 and take away 3, 87, and 87 plus 12 gives us 99, right? So all 3 subjects is 99, right? So what is left? We had 100, correct? So what is left for us is 100 take away 99. So that means there's one number outside, correct? So the answer is one person did not take any of these 3 subjects, correct? That is how we are going to answer it, right? So minus 99 gives you that answer 1. So I hope with this you have fairly good idea about application of Venn diagrams and how to do some word problems as we did just now. These are very critical questions and definitely in a test you expect them. So once you understand this strategy, it should not be very difficult. Hope you understand and appreciate it. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.